Okay, everyone. So we'll begin the demos. Let me give you quickly how we're going to proceed here. Every team is going to have a round of demonstration, and every team is as a team of 3 or 4 people. You have approximately 10 minutes to take us through your project, and then we leave 5 or 10 minutes for the audience to ask any questions. So the first team that is going to start the round of demonstrations is the team Cluster Champs. We'll give them a moment to share the screen and get on stage, and then we can show what's their wonderful project.
We will stand. We're going to be standing or
are we supposed to be in the screen on the camera?
I'll point the camera to you. So you do it however you're comfortable. Just share your screen, and I will take care of the camera.
Okay. No.
good?
Yep.
Yes. All right. So, ladies and gentlemen, allow us to, as a Cluster Champ, to welcome you on the 3rd edition of Astrolab for Data Science Bootcamp. And allow me to say a few words that even though it's been somehow of a challenging and long 2 months, they also have passed in a second, as regardless of how intense the bootcamp was and how sleepless nights we had. It's been a pleasure to be on this bootcamp and to reap the benefit of the knowledge of Danny and all the respected staff here. And allow me to introduce our first member, Zulfakar, and he'll start the introduction of our team.
Okay. Thank you. Sorry, I'll be using cues just in case. So
It's cool. It's cool.
So we are the Cluster Champs, and our project. Sorry, let's move aside. Yeah. Our project is for tech funding startups, and okay. The machine learning model for us is to predict the startup companies' ability to get funding based on the verticals. Sorry. Yeah. Sorry. Tech funding. I'm better off with this. Sorry, guys. Yeah. The machine learning model is helping to predict the startups' ability to get funding based on the verticals and region. And this is our team, consists of Hazem, affectionately known as Hamza by Danny, and Mujahid, a pure math lover. So just a little bit basic background about the data structure that we received. This data structure consists of over 3,500 companies across the world, ranging from starting from Jan 2020 to September. This data included various features like company labels, funding stage, funding data verticals, and funding amount, out of which we had a lot of problems with the data, as some of them were missing and some of them had just random stuff inside it. So the cleaning took a lot of issues with it. The initial EDA for us, we saw was there was a lot of funding to be received, out of which 70% of the funding was available in the US startups, of which and the 2 verticals that took over 30% of the funding was from fintech and B2B industries. Carry on forward. I think Mujahid will lead the way.
If I could jump here, can you also tell us what the data set is, what the problem is about? So if you can go back to the previous slides. If you could just briefly, quickly give us a background about the problem that you're solving and the source of the data. So I believe this is about tech funding.
Yes.
Can you tell us more about the tech funding problem that you're working on?
The problem was like checking out the probability of a startup company getting funding based on the verticals and the region at which they are coming from.
Okay, so with this problem, you're able to find out what kinds of companies.
How easy is it for a company to get funding based on the vertical and the region they're at?
Okay, so you have over 3,500 companies.
Correct.
And you've used machine learning to find out what is it about a company that allows them to,
Get funding.
gain funding.
Yeah.
Yeah. Yes, please continue.
Thank you. So for this project, we had a lot of well-established and well-known machine learning models that we could have used from regression and clustering and so on and so forth. But the main challenge was between using supervised machine learning or deep learning neural network. And we finally landed on that neural network deep learning would be the most optimal machine learning model to be utilized in this project, as it's much more accurate and has a much lower margin of error. And even though, regardless of the prerequisite conditions that need to be met and the technical difficulties in establishing the neural network, it was deemed that it's still the most suitable option. Therefore, we went with a very basic neural network that consists of an input layer, 2 hidden layers, and an output layer, as we decided that more than 2 hidden layers would be a bit overdoing it. So we remained on 2 hidden layers, as that seemed a reasonable amount of layers for this project. And after exploratory data analysis and feature engineering, we decided that the most important features in this project were the region and the vertical, as the region is just basically in which country or which geographical location the company is, as in United Arab Emirates, Saudi Arabia, Malaysia, United States, and so on and so forth. As well as for the vertical is mainly which industry the company is in, whether it's fintech, B2B, and cloud computing, ecosystem-focused companies. These 2 features were deemed the most important ones, and other features were disregarded. And for our label, it's simply the funding amount, which is how much funding did the company receive, did the startup receive in United States dollars. So yeah, this is my part, and I pass it on to Hamza.
Hi everyone. So I will go a little bit with details on how we use the machine learning and how the process we go through on this project. So first we took our data set, we did the feature engineering, removed the relevant features, and we used the train split method to split the data, 60% for training, 40% for testing. So in the 60%, we built the model, we built the neural network model, and we normalized the funding amount between 0 and 1. So it made our work easier and more efficient. After that, we trained the model. We found that the most important 2 metrics are the scalar scale and the minimum scale, that we could use them to reverse the percent from 0 to 1 to the real funding amount. Sorry. After that, we take the least 40% for testing, and we we use our neural network to predict and to see how much the loss and how much the prediction will gonna be after the testing. And we found that the percent of loss is less than 1.5%. So it's more accurate and so efficient. In the hidden layers, we use two layers, as Mujahid said, with the 100 density and 50 density. Yeah, and for improving, we could think to use the funding stage and clean it, so we could know. First, we clean it, we split it to 4 groups based on the funding stage. We could say, like, from creating the company till Series B, and from Series B to Series D, from Series D to Series E, and from E to above. Based on that, we could know that how much the success of this startup, like from beginning to Series A, it's in the beginning, and when we know that this company took an E series funding, so we could know that this vertical grab the investors to pay more for it. And for the conclusion, I will mention the most 3 challenges we met. First of all, the course was just 2 months, 2 intense bootcamp, and was 2 intense bootcamp with a lot of challenges. And the second, I will let Zulfikar to continue.
The challenges we faced was it was a 2 months intense bootcamp with most of us having zero or really limited experience in data science. And also me coming from an account background, even though this is fintech, it was a totally different ecosystem. So we had to go through it and understand what it was, the jargons and everything with the data we received. Again, it was a tough time balancing between work course and the project, since most of us are working. And the lessons we learned was that companies, if they have a really sound business plan, the funding is available for them, provided. And also in the current economic situation, as COVID or the COP20, there were a lot of companies, startups that have received money based on that. And
yes, during the situation of COVID, a lot of companies of food delivery and cloud services, and we could say the clean energy took investments. So we know that these verticals are growing so fast, so we could know that in the next generation we could invest and we could start with these verticals.
So
right? Yeah, that's it.
So this is the end of our presentation. It's been a real honor to be a part of this bootcamp. And I would personally say that one of the things that I'm planning to do or planning to improve as a data science or / data science student, to explore with more Python libraries and to dedicate more times for SQL skills.
So that's about it.
So that's
Thank you
about
very
it.
much,
Thank you so much.
Sure.
We'll actually take a few questions before we.
Yes.
Please, go ahead. Please.
We went to the social media straight. So you tell me when.
Yeah, let me bring your. I thought I can make this one myself and you can use one. What we'll do next is we'll give every team just to show open them to the audience for any questions that you have. If you have any questions, you can put them in the chat, and I'll read them out to the team. But let me start with a few. Now, the project you worked on is quite fascinating and very relevant to, the situation we're dealing with now. So towards the end of your presentation, you said that, there are 3,500 companies.
Yes.
And you said that there are 3 verticals that seem to get the most funding. You mentioned food delivery. What were the other 2?
No, not the most funding, but in the current, the number of companies
That are startups.
Yeah,
Like
the startups were a little high compared.
Food delivery,
Cloud services.
Cloud services.
take into consideration the COVID
And
situation.
green energy.
and renewable energy.
Green energy.
Green energy. You did mention the COP26 event, right? That has made a lot of headlines. But how many verticals were there in total, approximately?
Approximately almost 100. Yeah, almost 100 vertical.
So out of those 100 verticals, 3 of them stood out after you analyze the data, after you build a machine learning model, you find out that these are relevant to the current situation.
Yes.
How about in the future, if when COVID we have a better control over it, do you think it will continue to be that way? Or do you think these 3?
Well, yes, because it's estimated that even though COVID may hopefully be a part of the past, it has changed our life significantly.
Permanently,
It's possible not to go back to pre-COVID life, but to keep on evolving furthermore.
Okay. Also,
Anybody in the audience have a question?
yeah, does anyone have any questions from the audience before I come to my second
Thank
question?
you so much.
I have a silly question. What do you mean by a vertical?
Vertical means industry.
There's a question from LinkedIn.
LinkedIn.
Yes.
Cool.
Someone on LinkedIn posted.
Awesome.
How many features did you finalize and you have to sample data?
Can you repeat the question?
How many features did you finalize?
You mean post feature engineering and EDA?
Yeah.
Yeah, so in fact, that was my question. The question we got from LinkedIn is how many features did you end up with? So how many did you start with?
Well, initially we had a lot of irrelevant features such as the company's name, the website, the index, and
The
other
date.
features.
The funding date.
Yeah. So we finally ended up with 3 features.
2 features.
features.
2 features and 1 label, apologies. As in the industry or the vertical and the region, the country or the geographical location.
Okay. And just so the audience know what we're talking about here, can you just give a quick, simple definition of what a feature is and what a label is?
Well, basically, you could say it as in features are independent variables that they just exist on their own, and the label is the variable that's affected by said independent variables. And these features, they have their own weights, and by weight I mean how much they impact or they affect the label. The label is the thing we want to estimate, is our why. Is why are we doing this project and what are we hoping to find out or to understand.
So if you want to know how much a company is going to earn funding, you need to look at those features.
Correct.
Okay. Any other questions? How about in the chat? Anyone from the...
So before you dropped the funding date, did you look at kind of how funding had improved from the past now? Or?
I think it was just a 2-year period.
Okay.
It wasn't fast.
Oh,
It was just from Jan of 2020 to September,
Okay.
and we couldn't get any proper trend or something that we could analyze and explain.
There wasn't enough dates to establish a time series. So
Okay.
that's why the date feature was dropped.
And it was irrelevant. I saw like each 2 months, it doesn't depend for the funding. I saw the funding and the month, the funding and the period. There's no any link between them.
No correlation.
No any correlation. So we decided to remove it so it could affect our prediction.
Perfect. One last question, no more?
Come on, guys.
Well, thank you very much, the cluster champs, Hazem, Zulfikar, and
Pleasure. Thank you so much.
Mujahid. Thank you very much. By the the way, if any of you have any questions, even before, during, or after the teams have demoed, I welcome you to put your questions in the chat. I mean, since this is a data science demonstration, we are going to hear a lot of jargon, technical jargon. So some of you may be listening to this, to these terms, and be wondering what do they actually mean. So I welcome you to put this question in the chat, and I'll try to answer them, so just you're able to follow up. Now, the next thing we'll do is we'll allow the next team to prepare. So the next team we have are the sample guys. Sample as in statistical samples, right? We'll give them the opportunity to, prepare, and then we'll give them the floor.
Whoever came up with these names definitely is a race.
I agree. So the thing we do is, for all the participants, we put them into teams, and we gave them, clever names like cluster champs and sample guys. Sample guys, are you ready to demo?
Yes, we are.
Zoom?
Yes, we are in Zoom.
If you're on Zoom, one of your teammates can volunteer to share the screen.
Yes, I think I will start sharing this. Thank you.
And if I can ask everyone to keep, if you're not part of the team, please keep your microphones on mute. Otherwise, we'll have this feedback sound. Okay.
Hi guys, good evening. I'm really happy for this demo day. And yeah, so this is our data science project as a part of the Astrolabs Data Science Bootcamp. And thank you so much, Danny, and everyone at Astrolabs for this fulfilling journey. It has been very interesting to learn this new, I'm completely new to this field, and to successfully completed this data science bootcamp is like really a big achievement for me. So thank you so much. And this is my team. I'm Nifita. I'm sorry, I forgot to introduce myself. So, and me and Hergen would be doing the presentation for today. So this is my other teammates, Maita and Dominic. So in this data science project, we were detecting the fraud transactions from the banking data set, and we were trying to come up with a machine learning model which can detect whether a transaction is fraud or not fraud. And the data sets consist of payments from different customers made in different time periods and with different amounts. So let me just take you quickly to the importance of this project. Why do we have to come up with to detect fraudulent transactions? Fraud is costing billions, trillions of dollars actually each year for businesses, and it is an uncontrolled expenditure. And so as everything is happening online nowadays, from shopping, banking, insurance, fraudsters are taking advantage of all these loopholes. And before any professional can come up with a solution, the damage is already done. So fraud transactions happen online when fraudsters use stolen credit card informations, or they even use the fake credit card informations to do the transactions. So this, even though in finance, there is an automated system to look after everything, but this kind of fraud transactions can create a very big impact on this. So what is the solution for this? Banks can use the machine learning models to accurately detect patterns of fraud transactions and prevent them by learning from the past data. And these statistical models can reduce the risk and keep the finances safe and the company running. So this machine learning model is primarily important because it can process vast information faster than a team of best analysts can. And the more data you give machine learning model, the better it can perform, which is difficult for humans. So let me get into how we did this. So these are the basic steps we did. First, we do the collection of data, and then we extract the features. Features in the sense we look into what are the things that will decide whether a transaction is fraud or not. And we then train the machine depending upon all the data, and then we create a model. So coming to the exploratory data analysis or the feature extraction step, this data set is having 9 features, and features are the things that determine whether a transaction is going to be a fraud transaction or not, and that is our target column. So the features are step. This feature represents the day from the start of the stimulation, and it has 180 steps. So stimulation ran from virtually 6 months. And the next feature is customer. This feature represents the customer ID, and we have zip code origin of the source and the merchant ID. And we do have the merchant zip code. And the age is categorized into 6 plus an unknown category, depending upon the age group. And gender is primarily female and male. And we have ignored the unknown and enterprise because there weren't much transactions in that. And the category of purchase and the amount of purchase. So this is the target variable. Like we are going to find out, depending upon all these features, whether the transaction is fraud or not. And coming to the first feature, this is the transaction, the count of how many transactions were fraud payments. And from this, we can understand like it's just 1.2% of the number of transactions that were fraud, that is 7,200 to be precise. But when you look into the amount of transactions that were fraud, it comes to 17% compared to 83% of the non-fraudulent payments, the amount of transactions. And coming to the next feature, this is category. So these are the different categories we had: transportation, food, health, wellness, and beauty. So transportation and food being the largest two categories, it is surprisingly and pleasantly good that these two transactions didn't have any fraud at all. So when you look at the fraud transactions analysis, you will find the other categories like sports and toys and health sector having the highest of fraud transactions. And then we did analyze regarding the age. So we found like the age category of 2, that is 26 to 35 years old, are the ones who is obviously doing most number of transactions. And then when you analyze the fraudulent transactions, it is more or less at par, most of the age group, except that the 0 age group is like, which is less than or equal to 18 years, it's come a little bit higher. And then we are going on to the gender-wise analysis. In the gender-wise analysis, yeah, of course, women love to purchase, and then the female transactions have come the highest, the number of transactions. But even in fraud, also the female transactions have come higher. So don't know why. And so that's it, a little bit of the feature analysis, which will be continued by my teammate, Hergen. Over to you. Thank you.
Okay, thank you very much, Nafisa. That's excellent for start. Can you please stop sharing so I can share my
stopping this moment, yeah. Yeah.
Good. So I hope you can see my screen.
Yes, we can see your screen.
Perfect. So after we went through the initial analysis of the data, so we assumed that the zip codes of the merchant, so they were both for the same for all entries. So we decided that we can definitely drop them. Regarding the other features like customer, age, gender, merchant, and step basically being a day. So the data set was across 180 days. So each step represented 1 day. So we were assuming that we also could drop these features because transactional fraud transactions were assumed to be like single case actions. And so we tried our first attempt with just the category and the amount, what actually ended up with no relevant capability to predict any kind of fraudulent actions. So we went back and had a look, what kind of fraudulent transactions do we see? And we looked at the worst merchant, or worst in that case, at having the most fraud actions. So that what amounted to 1,600 cases. keeping in mind the total data set includes 7,200. So this was quite significant. But it turned out also it's not 100% of the transactions that are fraudulent, but yeah, roughly, I would say like 40% or something. So then we looked at how do these transactions actually progress over time. So we looked at all the customers, what kind of initial transaction happened and what kind of fraud. And we were, I mean, looking at this, it might indicate that always there's a transaction and then fraud happens afterwards. So we then continued looking into the details of the customers with that were worse hit. And it's interesting to see that, well, we see in the first one, yes, there's a non-fraud transaction and then multiple transactions. So it's really interesting to see how heavy some customers were hit by fraudulent transactions, something that initially we didn't expect. And also the time aspect seemed important. Then we looked into details. So we picked one of them and we looked into the details. So how does one customer is affected by transactions? So our assumption would be that, yeah, if the merchant is the one benefiting from the transaction. So, but it turns out that this customer was hit hard by a lot of the money went to different sources and developed over time. And then we looked as you can see, in general, this is true that there's one transaction that is normal and then other transaction fraudulent happening, but it also happens the other way around. So we looked at one specific set where it's the other way around. We want to know why. So it's very difficult by just looking at the data to identify what could be logical reasons for fraud or for the fraud or for the baseline, how machine learning could help and what kind of information or features are actually useful. So we then did a second attempt and actually converted the categorical features into numerical features, meaning customer, age, gender, and merchant, because we actually couldn't exclude what kind of correlations were between these features. So we ended up with a data set looking like this after data engineering. And yeah, tried our first attempt with a neural network. It was able to identify we split the data into a train data set and a test data set. And when we ran the test data set, so we had around 230,000 cases, and the model was able to predict 2,300 fraud cases, of which only 1,800 were actual fraud, with 510 wrong detection and 900 misdetection. So we concluded that this is not really a good model to predict fraud, because it's too much false positive and false negative. So then we went back and looked what other model we could use, and we knew that for binary class detection, we knew from an earlier data set, the random forest classifier was a good approach, so we used that, and ran then a 60-20-20 split with hyperparameters of 5, 50, and 100, and the maximum depth of 2 and 10. What actually could have been improved, but the initial results were quite promising. So we chose the 3 best ones and ran with it on the test data set, and received an accuracy of 99%, precision 90%, and recall of 0.7. What all looked pretty okay. and even started to run a fabricated data set with transactions, and yeah, somewhat got results that were expected. But the moment we started adjusting information, like changing the merchant or the customer, the results really became, I would say, not necessarily helpful. And one reason was probably that we rather than using one hot encoding for the categorical information, we used numerical replacement. So what probably confused the model, because if you're giving a customer, for example, just an ID, it might assume customer number 1 is in relation to customer number 2, and that might have led through a quite high prediction result, what actually turned out not to be the case when we tried to run it with one hot encoding. So, conclusions. Predicting fraud requires a complex analysis of time-related data. What we tried with our data set was we just split through, we allowed a random split through the data. What might have made a good prediction impossible, because there's a correlation of transactions. But we were not able to actually split the data in a way that maintains the logical connections between the transactions. So second, it's quite challenging to identify what machine learning model actually works the best with what data on what features. So coming to the top challenge we were facing identifying a suitable machine learning model, deciding on valid features, detection capability versus accuracy, so false positive, false negative. What is really a good model that works, and how usable is it in a real life scenario? So concluding that it's time relevant. It's not that you teach a model once to predict fraud. It really depends on the information that you feed into the model on a constant basis, to allow after multiple transactions to determine the results. What is an assumption that we weren't able to prove. Top 3 lessons learned. So listen to a few hours of machine learning narrative does not make you catch thieves. Subject matter expertise could have helped us to really understand how can this data be interpreted in a more meaningful way, more strategic way. And becoming a useful data analyst is definitely a long road. And next step will be learn more and get better. And that's our part, our experience regarding detecting fraud.
Thank you very much. Birgit and Nafida for this very detailed demonstration. Now, what brought me, if it's all right, I'd like to ask you, it's more of a comment than a question, but what's impressive about your work is the nature of your data. Not only is it limited in terms of features, I imagine you have to do quite a bit of engineering, a lot of cleaning to even work with this data set that has relatively small number of features from which your model can learn. If you could take us to the previous slide. Another thing that I found fascinating is, even though you were working with an especially problematic data set, you tried different machine learning models. So I believe the first one was a neural network, and the second one, I believe you used a what was the second model you used?
Reinforcement. It's the reinforcement.
And do you think you could have improved? Now, you did mention that the model it could definitely be improved. But do you think the improvement can come from a different type of model, or it's just a matter of the data? If only you had more data, you could do a better job at detecting fraudulent transactions.
I think what would have helped us is having more time and more skill regarding how to do. So
Okay.
learning on the fly, trying different things, seeing results, assuming they're right, and after certain consideration realizing maybe not. So it's which model to use. We have no capability to determine what is a good model, what works better. There are methods to compare them, what we not methodologically explored. So we were just trying to see what we can make work and what kind of results come out at the end.
Perfect. Thank you very much. Questions from the audience? Anybody have any questions? How about in Zoom? If anyone has any question in Zoom, you can. I welcome you to put your question in the chat. No questions? Anybody?
Can I have one?
Sure.
Can you go back for the slide of how much fraud and not fraud?
So the slide is showing the ratio of fraudulent and not fraudulent transactions.
Yeah, like what do you mean of fraud and not fraud?
So basically, the data set included almost 600,000 transactions, out of which 587,443 were genuine and 7,200 were marked as fraud. The intention was on this basis to learn how to predict.
So there was only 1%, 1.2% of for them of fraudulent transactions from which the model could learn its parameters.
And what is the percent of money that is fraud based on?
17%.
70% of the amount.
Thank you.
Thank you very much, Hergen and Nafida, the sample guys, for this very wonderful demo. One more round of applause.
Thank you very much, and thank you, Danny, for your constant attempt to make us learn.
My pleasure, but I mean, this is you need to give yourself more credit, of course. In fact, while we are prepared for the next team to prepare, which is the Systematic Squad, that's a pretty cool name. Let me give you some perspective for those of you who just joined us. Let me give you some perspective. The teams who are demoing, and Hergen kind of alluded to this. Everybody in this bootcamp, they were not practitioners of data science. This is something they've got into the first time. I think maybe one or two people may have had some learning on their own, but apart from that, this is something they're completely new to. So, and if you don't know, this program is 2 months long, just 2 months. And as Mujahid said, the participant from the first team, it is quite intense because in 2 months, you're expected to learn everything from the fundamentals of data science all the way to the most advanced concepts of machine learning, like deep learning and something we call machine learning metrics, which is another word for understanding and interpreting results from statistical tests. So maybe for those of you who are interested to learn more about data science, maybe once we're done with the round of demos, we can have a Q&A for any of you who have any technical questions, because like I said, since every team has 10 minutes, in a 10-minute span of time, a lot of technical terms may be thrown around, and some of you may wonder what do these things really mean. But until that time, let me give the floor to the team Systematic Squad. If you are ready, can you please share your screen? Just questions I have.
I'm going to show you now.
Yes, please.
Hello, my name is Noor. Our team is the Systematic Squad, and we chose the COVID-19 dataset. Yeah. As I said, I'm Noor Hamiduddin, and my teammate, Zainab. I will be introducing our project today. Next slide, please. So we chose to use the COVID-19 dataset. It's the data from from all the countries in the world. As shown here, this is a sample of our data. So we have the country, cases, deaths, recovered active cases, and then also the tests that have been made in each of these countries. So when looking at our data, it was hard for us to figure out what we wanted to do with the data, what our problem was. So we actually ended up adding columns that will help us find the severity of the COVID data around the world. So our problem definition was, can we determine the severity spread of COVID-19 among the different countries? Next slide.
As Noor said, the main aim of this project is to classify the countries or to determine if the country was having a high death rate or a low death rate. After researching, we figured out that we need a way to measure the fatality of a country. So we saw this equation, which is the fatality ratio, which is basically taking the number of deaths of a country from a disease and dividing it by the confirmed cases of a disease. And we already have those two information in our data sets. So what we did actually is that we added two columns, as we can see in the right corner. We have high and low death rate. We determine if a country has a low or death rate, which is, for example, here true, meaning that they have a high death rate, false, meaning they have a low death rate. And also we calculated the death score based on this formula. So if you can see here in the graph, what we did is basically we calculated the death scores and we determined whether a country has a high death rate or a low death rate based on the mean. After graphing all the countries, we graphed the mean of the death rate or the fatality ratio, and it happened to be 1.5% of the total cases happened to the people who got COVID. 1.5% of those people, they ended dead on average. So any country that had a higher death rate, we categorized it as a high death rate country, and other countries with a low death country. Then we try to graph those countries based on the total cases versus the death cases. And as we can see, those countries with high fatality ratio were in the orange, and the low death ratio were in the blue. So the purpose of doing this is that we want to build a machine learning model that, when given a total test case and a total death rate, it will be able to categorize this country to either be blue, meaning they don't have a high death rate, or to be in the orange side of the graph. So to build this model, we used random forest classifier, which combines both being supervised, meaning that these information or the data set that we are going to give to this machine learning model is labeled as we did, and also to be able to classify whatever information we have to categories. So to give you a really overview about random forest classifier, imagine that you have a big forest, and in this forest you have multiple trees. The purpose of each tree is that it's going to be a decision tree. Like as we can see in this slide, we have, for example, 3 trees. Let's take the scenario that we have for the COVID-19 set. So one tree, when we give it the information about country, it will say, for example, this country has a low death rate. Another decision tree with different like branches, it would make a decision that this tree actually has a high death rate. And the third one, let's say it said that this country, no, actually it has a low death rate. What this model does is that it's gonna average all of these out and it's gonna take the majority. For example, here we have low death rate, high death rate, low death rate. The majority is to have a low death rate. So the final decision of this random forest tree, it would be, for example, low death rate. So that is how we were able to classify the countries into 2 categories. So the results that we have here, we are talking about the results after building the machine learning model. To build our machine learning model, we splitted our table with the data set with the label countries into 3 categories: training set, validating set, and testing set. The training set, the purpose of that is just to train this random forest tree to make decisions. We give it the data and the labels. And then we try to validate these information by predicting some of the data sets. We give the machine learning data sets without labels, and we were trying to see if they were like matched to the right labels. After that, we were trying to test our model, and we got an accuracy of 84%. Like when you give the machine learning model information about the country, giving them like the total cases, the death rates, it's going to be able to predict 84% of the time if this country is having a low death rate or high death rate. Finally, what we did is that we made up countries to see if this machine learning model is also able to categorize these data. So we created a country that is having only 5 deaths compared to another country that is having 500 deaths. And eventually our machine learning model was able to identify the first country to have a low death rate, which is true, 5, it's not a lot, and to have a high death rate for the other country that was having a 500 deaths per 1 million population. Possible ways to improve this project is to use unsupervised machine learning model. What we did, which is appending the 2 columns, the labels, was to be able to use a supervised machine learning model. It would be cooler to not append any columns, but that would require us to expand our data set to have more information about the countries, including the GDP, for example, about a country, whether this country has a good healthcare system or a bad healthcare system. But with the limited information that we have about the countries, we decided that we want to label the countries and just categorize them. In the conclusion, the challenges that we faced as we discussed through this presentation, we were finding a trouble in defining the problem. Given this data set, we were struggling to see the value of this data set. And also we were not sure about which machine learning model we need to go with, because it was not fully labeled. We didn't have fully labeled data, if that makes sense. The lessons that we got from this is that through researching, we got, for example, the fatality ratio equation. We learned about how we can categorize countries. And also we actually found out the value in our data set. And we figured out that each data set would eventually have a value in it. And thank you for listening.
Thank you very much for that very wonderful demonstration. So systematic squad, you chose to work on a very, you know, a problem that is very, well, it's something that, you know, is constantly in the news. I think we have a new variant of the COVID virus, all kinds of questions from economics to logistics to employment. I mean, you name it, this topic that you chose to, or this problem that you chose to explore, you know, has affected every aspect of our life. I want to ask you something. You know, since you have insight into the data, one thing that you know caught my attention is that the mean average for the death rate, if I'm not mistaken, is 1.5%.
Sure.
Is that correct?
Sure.
Yes.
And since you have insight into data, can you tell us which countries have been affected the most? Like which countries have suffered the most fatalities?
I think Brazil, if I'm not mistaken, but there are countries that had a really high death rate, and we had to eliminate those even like in our graphs to show like the countries that were not having a high death rate ratio. There is a country that had a death rate ratio of 20, which is really high. 20%.
20%.
Yeah.
Why do you think that is? Like, what is it that makes one country more susceptible to death rates? Do you think this is something you were able to learn from your data science project?
I would say with the data set that we have, it was limited information. Like we only had, maybe we were like thinking about insights about the number of tests, but we were not able to go into that a lot because we had phrased the theory that a country which has more tests, apparently it has a better health system kind of. So maybe a country that has lower number of test samples, it might have lower healthcare system, but we were not able to go into that area. But for example, information about the economy, the GDP, stuff like that might give us insights about why is that the case. But
Okay.
yeah.
Yeah. So no, you said GDP. So I guess that's one thing, at least that you discovered, right? GDP. Well, you're right. I mean, if you want to, if you want to become more, let's say, accurate, you do need more data. And how many features do you have? By how many explanatory variables were in your data set?
1, 2, 3, 4, 5.
Five features.
Five features, excluding the country because it's just like a label. So we will say 4.
40.
Case 4, yeah. Cases recovered, tests.
Okay. Thank you very much. Any questions from the audience?
How would the new variants of COVID affect this data, these findings?
So the question is, if you didn't hear, is how is the new variant of this new COVID variant, Omicron? How is that going to? How do you think that will affect your findings?
I think it's going to affect it dramatically because now it is basing this on a mean. If the mean was like different, then everything will be different. Like if that variance was severe and like killing people, for example, this machine learning model needs to be trained again with larger data sets.
Okay, thank you very much. Any other questions? Well, thank you very much, Systemic Squad, for the interesting problem. That's it. Round of applause for you. Okay, before we switch to the next team, we will take a short break, a short 5-minute break. In the meantime, I want to allow our guests on LinkedIn and YouTube, and some of you here on Zoom, to ask questions. Now, I imagine some of you who are watching this, especially some of you on LinkedIn and YouTube, are wondering, what it takes to get into data science, and you may be considering this bootcamp yourself, and you want to know, maybe, are you prepared for it, or for that matter, what do you need to know to even start your learning journey in data science? So if you have any questions, you're free to ask. If you don't have, I'll jump in and I'll give you some pointers, during this break. So data science, let me tell you, data science is a discipline. I'm sure most of you know that this is new, and it's if you go on LinkedIn, if you look at blogs on YouTube, you'll find a lot of posts, a lot of video posts, a lot of blog posts talking about data science. That this data science, is now a big deal. So, what do you need to learn to get started with data science? So this discipline, data science, the discipline, there are three aspects to it. There are three things that a data scientist must be competent in. There are three things that they must be good at. Programming is one of them. I'm sure most of you heard that Python is a programming language. It has something to do with data science. So computer programming is one of the three things you need to have if you want to, become a data scientist, if you want to learn data science. Now, I would say more generally, it's computer science, not just programming, but computer science is actually a very broad field. There's more to computer science than just programming. But for starters, programming is number one of the three things you need. Number two is statistics. And to be more precise, statistics and probability theory. So data science is a mathematical discipline, and almost every concept in data science is borrowed directly from mathematics, but in particular statistics and probability theory. In other words, the second skill you need to have to become a data scientist is literacy in statistics and probability theory. And I say statistics and probability theory because these two topics are closely tied to each other. Now, before I tell you how you can start with statistics and probability theory, let me tell you about the third skill that you need to get into data science, and that is domain expertise. And when we say domain expertise, we mean expertise about particular industry. For example, you can have domain expertise in healthcare. You can have domain expertise in the automotive industry. You can have domain expertise in epidemiology, right? So we were talking about COVID, the spread of diseases. You may have domain expertise in that. You may have the domain expertise in sales and marketing and real estate. So you cannot just learn technical skills and practice data science. You also need to know how to apply those technical skills to a particular domain. So if you want to become a data scientist, it's best if you have some experience with some domain beforehand. In fact, that is actually a huge advantage. If you're someone who's been in sales, in healthcare, in banking, in education, any domain for 5-10 years, and you're considering, or let's say you're wondering if data science is something you can get into, the answer is yes. In fact, you would be the type of person most companies would want. They will. Most companies who want to, get into machine learning, adopt machine learning to help them with their business or organization, need people who are more than just mathematicians or programmers. They need people who understand the problems of that domain. Now, let me see if any of you have any questions in here. I don't see any questions. So let me tell you how to get started with statistics and probability theory. Now, this is probably the most challenging part, the most challenging skill of the three we talked about. Okay, so we have programming, we have statistics and math, and we have domain expertise. The second one is the most challenging, and for two reasons. Well, you probably all know that math has a reputation for being a very difficult subject. And there are two reasons why that is the case. Reason number one is, well, mathematics is a humongous discipline. Mathematics is a huge discipline, and it's the foundation of physics, and by extension, the different engineering disciplines, so electrical engineering, mechanical engineering, water engineering, all kinds of engineering, all have one thing in common, and that's mathematics. So how do you make it easier to learn mathematics for yourself? Let me tell you that there are two problems, or there are two things that you need to be aware of when you want to learn mathematics, right? And data science does require knowledge of the different branches. So you need to know statistics, you need to know probability theory, you need to know calculus to some extent, you need to know linear algebra, especially if you're talking about neural networks, and deep learning, which is what some of our teams are demoing here. You need to know linear algebra for deep learning. There's also another mathematical branch called optimization. So there's not one book that you can pick up, or two books that you can pick up, and that will, that will be the end of it. You actually need to be able to, you need to have the ability to learn these different mathematical branches. How do you do that? Well, there are two things that you need to keep in mind. Number one is the symbols used in mathematics. The symbols in mathematics, right? The plus sign, the minus sign, equal sign, all those Greek letters you may have seen, all those equations. So you need to know what those letters mean. Okay? That's one of the obstacles. The second obstacle is terminology. Now, so you have symbols on one hand, you have terminology on the other hand. And since these are your two obstacles, you need to find the resources that will help you tackle these obstacles the best way. And what are those resources? Well, it turns out that they're textbooks. And one thing we advocate here in this bootcamp is to have less reliance on YouTube or videos on YouTube or posts on different blog sites, because while learning from the internet, like through Wikipedia and YouTube and blogs, are great, you have a lot of resources. They are rarely, they're rarely structured. They rarely tell you where to start and where to finish. And the resource that does that best, that tells you what to start, where to start, and where to end, are books. Now, if any of you are interested in, there's actually a reading list that we've compiled for this data science bootcamp. And if you're interested in what that reading list is, so you can have a look at yourself, I welcome you to actually share your email with Amr, who's here in the chat, so we can email that to you. Let me see if anyone has any questions. I don't see anything on LinkedIn. But if you do have any questions, even once we resume the demos, I welcome you to share your questions. And we'll begin with the demos in a minute. Team, significantly different. Are you ready for the demo? So if you can prepare your slides, because we'll resume in a minute. Okay, great. Okay. Just give us a minute, and we'll I'll give you the floor so you can proceed with the demonstration.
Yeah, I'm still getting used to what people want to do with COVID.
You guys were the most prepared, so.
All right, so now we'll resume. And next up is significantly different. Please start your demonstration.
Hello, everyone. So our project is personality analysis for a marketing campaign. I'll introduce the team. It's me, Osama Lubade. I'm a project manager in Bureau Veritas, and I have my colleague Hala. She's not here today. I'll proceed alone today. So we'll start with the problem definition. It's a problem that is mainly concerns a lot of companies and organizations, is how to target their customers and to target the right customer specifically. Like out of their data that they collected throughout, let's say, the loyalty campaigns or the loyalty customer programs, they collected a lot of data about their customers and categorized it. And out of this data, they need to target a specific segment of their customers in order to make more profits, or let's say target their marketing to this specific segment or this specific category of their customers that will be interested in buying more of a specific product. Now, what happened is, like, some companies or some organizations, they start sending marketing campaigns haphazardly and annoy their customers, and eventually to deter their customers from coming back again to buy a product that they are really interested in. And this is considered like a lost profit to this organization. Now, the data set is provided by Akish Patel. It seems like he collected it from a project he was working on. And the target is out of this data set. Our target is just to make categorize or group the customers in order to build the strategy for a company to target their customers with the specific products they are really interested in. Okay. So the exploratory data analysis that I did in this data set, it's basically, this data set consisted of 29 columns and 2,240 observations or rows. Out of them, I filtered them to nine columns, and 9 columns that we will call the features or characteristics of our customers, and 1 column or label that we are targeting here. We are targeting our customer. So the data consisted of characteristics of the customers, like marital status, education. As you can see here, the data consisted of like single, married, together, separated, widow. So in order to analyze the data properly, I grouped them into a relationship or not in a relationship. Similar approach I followed in the education. As you can see here, the data had an observation of graduate, PhD, master's, and second cycle. So again, I grouped them to education, like graduate or non-graduate. As you can see, the count is similar, or matching 2,000, and here 2,204. If you sum all these histograms. Second was the age. This was not specifically mentioned as an age column. It was the date of birth. So again, I did some calculation and added a new column called age. In this age, I had 3-4 outliers. I removed them from here, so it's transferred and cleaned here. The outliers also, I noticed them in the income here. This is like a typo error. I removed it, and eventually I get this box plot, as you can see, which has some outliers here, but they are okay to keep them. The same issue I had in the kids and teenagers. Basically, it's both are similar. 0 kids here, one kid here, and 1 teenager here. Again, it can be grouped in one category, 3 categories, like 0 kids, 1 kid, 2 kids at home. And accordingly, I did some analysis to understand what patterns are going on in this store, who is buying what, let's say. So here, if you notice the age against the items purchased, you can see the age groups that are buying the wine and fruits, meat, fish, sweets, and gold are similar. Like you can see from 20 to 60, basically it's the same pattern. This is the age group that is buying the product. Similar approach in once you analyze the marital status before grouping. If you notice, like here, it's like the married. Again, the same pattern repeats itself here. Again, here the pattern from the education. Again, the same pattern repeats itself here. Again, it's like graduated personality or graduated feature, who buys all this stuff. Now, after I completed all the cleaning, again, I checked for the outliers. Again, here I kept it, this one 3 points outlier. As you can see from the columns that I kept, which are the income, age, how many deals they purchased, how many purchases they did in each time, and offers that they accepted, coupons, and how much they spent on each item and each purchase. Now, this is the clustering, the data after clustering. I clustered I had 4 groups of customers based on the data that I had. And as you can see here, most of the purchases are on wine and secondly on meat. I don't know, they are selling good wines. Again, here, the same pattern also emerged. If you can see, I plotted like a graph that shows the average of each purchase for each category of the customers and for each product. Now here also after the cluster, from the same data, what clients, who are the clients who took part in the promotions from the data that I had, and the participation of each cluster of the data, who accepted which promotion. Okay. Next, who was complaining? There was a field after clustering. I grouped, I returned back the data, returned back the clusters, and I categorized who is mostly complaining. Now, again, this is the conclusion that I got. Like the main target is this one. Mainly, these are the complaining guys, the complaining customers. You can see what's the percentage of each. Sorry, it seems like a typo error or mistake here. Now, the machine learning model that I use is k-means clustering. Now, these are the features or the, let's say, the characteristics that I use to analyze the data and compare them against the label, which is the total spend. Okay. Now, here there is, as you can see, this is the scattered plot, which shows each cluster and against how much they spent and their income. This is the most the two features who are like correlated heavily. As I was speaking about the outliers, you can see this is the outliers here, and that they have higher income, but again, they are captured very well. Here you can see also another graph that shows how many numbers of customers. This is on the code. Once you hover, you can see the count. The same 3D scattered plot I did, which is similar to the 2D, but this is 3D. Here you can see also the correlation matrices that shows which is what characteristics or what features are heavily correlated. As you can see here, it's the income with the total spend. Basically, you can see the higher income, the higher you spend. The same scenario here is just only a different approach or different figure. It shows what's the correlation here between the income and the total spend. Now, here, one of the issues that I faced is how many categories or how many groups I should select. This is basically solved by the elbow method. Here, as you can see, the optimum number of clusters or optimum number of groups is 4. The same here also I recently added is how to select the optimum number of our clusters or optimum number of our customers using the cellulate algorithm figure. Now, my conclusion here, basically the issues I faced is really data cleaning and categorizing the data and putting them in a properly. And the other issue is what's the optimum number of clusters, or what's the optimum number of our customers group? Is it 3, 4, 5, 6? This will affect the data heavily and will affect the decision also as well. The second thing is the lessons I learned is really take time to clean the data. K-mean cluster is the machine learning models, unsupervised machine learning model that I use, is very sensitive to outliers and the initial centroid that once it starts, do it yourself and don't wait for others. Of course, as Danny was saying, is to find a reliable source of reference source, basically books, and learn to ask the right questions.
Thank you very much, Osama.
Welcome.
Now I know that you had only 2 team members, and you were the only one who had to demo today. So that's especially, impressive that you had to do this demo on your day. This demo by yourself today.
No, it's okay.
Now, what I do like is that we know in clustering, the machine doesn't actually give clusters names. So just go with 1, 2, 3, or 4, but you actually named them, and it was. Yeah. I found it quite amusing that you have something called cheap client, right?
Yeah.
These are the people who come to the store, ask questions, they complain apparently, but they don't buy them.
Yeah, exactly. Yeah.
And I think though, for those those in marketing, this could be quite interesting, right? Because after all, you have to spend a lot of time and money to plan a marketing campaign, get in touch with the advertisers, to advertise in different mediums, and all that money that is spent on digital and non-digital advertising, only for these ungrateful people, right?
Yes.
Ungrateful people who just complain.
Yeah.
Who just complain about the YouTube ads or the Facebook ads.
Yeah, exactly. Yeah.
Exactly. Yeah. This is quite fascinating, and the way you wrapped up the conclusion, I mean, that was great. No questions from me. Any questions from the audience? Question from Heba? The matrix, yes.
The yellow or the bright lights color. What is the negative correlation? What is the feature that is correlated?
So the question is, what is that feature that negatively correlates with?
Okay.
I think this is. Well, I can't see, but if you can tell us.
Yeah. See, the negatively correlated features are age, kids, and the number of children. Sorry, total. Let's see. here, age, kids mainly, and ID. For sure, this is removed actually, but I did it here just, I kept the ID actually, because in the end of the code, I had to return it to the cluster. So recently I was reading about the join method. We didn't encounter in the bootcamp. So again, yeah, but I during the project, or once I did the code, I kept the ID. It should be dropped actually, and I dropped it. But eventually, in the end, I had to keep return it back to cluster to put the cluster feature to each client and make sure that it's not duplicated.
So you said negatively correlated. So are you suggesting, or are you implying that the older the customer or the more kids the customer has, the less likely they're to spend money?
Yes, yeah, but it's not really quite well, because let me share the code. Just one moment.
Maybe that explains why kids cry so much at the mall, right?
Yeah. Just one moment. Let me share and reconnect.
So if the customers are older and they have kids, forget about that.
Yeah, basically you can say that. Yeah. See, the main feature actually is the income, mainly the income and total purchases, the age and how many kids they have. As you can see from the same pattern, married are the higher spenders. So there is no much, there is no inference or like insight getting it of. Mainly your main target is someone with kids, either separate, either like single father or single mother with a kid. This is the main customer, because they are spending more. As you can see from the patterns, they are spending more also as well. However, it's negatively correlated. Doesn't mean it's like will affect the clustering. You can see, because the main feature that I used is the income with the other features.
Okay, now once if you I don't know if you're sharing your screen, but
one moment, yeah.
I just wanted to see if anyone has any other questions for Osama. Now, by the way, what was this data set about? Like, it is purchased, but do you know what? I mean, what were the what kind of purchases are we talking about? Are these department stores? Are they electronics?
See, there was three features are there: website purchases, store purchases, and catalog purchases. So I was not quite understand. I couldn't figure it out. Is it like a website or a store? But the items they are selling, it seems like a store, because wine, you need some some storage area, and it should be stored properly. Okay, and meat also, it should be stored properly. So I'm guessing like it's a supermarket or a department store. This is my guessing. However, it's not mentioned.
Yeah, that makes sense. But I imagine if you did have more information, you could definitely repurpose.
Yes.
You could definitely repurpose your work.
Yeah, one moment. Let's share the screen. Okay. So you see here the 3D model.
Oh yes.
Yeah. See here, it's like it's clustered here, like how many purchases and what's the income and how much they spend. Okay, the same on the scattered diagram, but it's like here you can easily get see the clusters or see the groups.
No, that makes sense. Well, obviously, the more they earn, the greater the disposable income. The more disposable income they have.
Exactly. Yeah, the main feature, like kids or not kids, they have to spend, because the items that they are purchasing is like necessary items. It's not like luxury or good to have items. Like, okay, wine, I understand, but I don't get the reason why they are buying wine for the kids. I doubt it, but they are buying it, and it's like the major, the total spend is high on the wine.
That makes sense.
Yeah.
So even a 3D representation of your data set, very fascinating. Well, thank you very much, Osama. Good luck to you with your future in data science. It was a very demo. Last but not least, the team Data Whisperers. are going to take us through their presentation. Just give them a minute to, prepare the computers so they can share their work with us. Go. Yeah, maybe you can turn off your mic. I'll turn off.
Okay, I'm go through the site. Okay. Cool. Hi everyone, we are the Data Whisperers, and we're going to take you through the power of words. So we focus on sentiment analysis for Amazon reviews. We're going to go tell you a bit about ourselves, explain our problem, take you through our exploratory data analysis, and then we're going to go into our machine learning model and our conclusion. So you're going to need your phones for this section, so could you please take out your phones? Sorry, we'll introduce ourselves first. My name is Amber, and I'm a data manager at student accommodation.
And we have Bavia. She might be in the audience, but maybe she's a bit sick.
Hello,
I'm not sure.
I'm Bavia Baby.
And I'm Hiba. I'm a renewable energy data analyst at Enlight Energy.
I'm Sushma. I work as a clinical data specialist in one of the nearest hospital which we have, that is King's College.
Amazing team. Okay. So as I said, you're going to need your phones. Do you mind just taking a picture of the QR code? Sorry.
Even online, people online can also just
scan that.
Or you can just go to www.menti.com and enter in the code.
Okay. You can press on the like button so that we know how many people are joining us.
Maybe two of you like us.
Three.
Yep.
Just make it good.
I think if we
make
have
sure you
mic-
hit the thumbs up.
Yeah.
Yeah, make sure you have the thumbs up.
Make sure you hit the thumbs up.
Yeah.
Okay, should we just go ahead?
Yeah.
Okay, so we're just going to do a bit of a poll. Yeah, next slide.
Maybe
Could you guys see?
to see the code.
Oh, sorry.
Thank you.
Okay.
Okay.
Okay, cool.
All right. So now we have 5 people.
So next one. I think we've got. Okay. So have any of you ever shot someone?
Yes.
You never know. People
Yeah,
are
there are.
anti-online shopping. As expected, 100%. So our next question. Do you read reviews before purchasing a product or service? Yes. So that could be a hotel, or looking at what customers did before, or just like a simple Amazon purchase.
Some people seem to be risk takers,
I guess it also depends on the price of the product, isn't it? Maybe something cheap, you just okay, so 60%, 40%, it's quite interesting. Next question. Have you ever been swayed or deterred from purchasing a product because of reviews? So if something was negative, you chose not to buy it, or if something was positive, it actually pushed you towards buying it. Who doesn't trust reviews? Okay. Interesting split. So I tend to review reviews, to be fair, and it does definitely sway whether I purchase something or not. So, going on. So, sentiment analysis. What is sentiment analysis? Sentiment analysis is a feeling that could be good, bad, happy, sad. You are presenting how you feel about something. And we're going to be using sentiment analysis, which basically uses categorization to process data to find out insights from it. And our data source, as we mentioned, is Amazon. So we just thought we'd give you an example of some reviews within our data to kind of show you the different sentiments. So Amazon uses a 5-star rating scales from 5-star, which is positive, to 1-star, which is very negative. So like 5 stars, they actually put 5 stars in there to kind of show you that they were happy. And you'll just have very positive words such as awesome, super, great price. And then compared on the other end to your 1-star rating, where you have someone who's very disappointed. And they reiterate at the end that they're very disappointed. But they're talking about like the size, the quality, etc., etc. And if you come to now someone in the middle, I guess it's kind of more for neutral because they're talking about the fact that the sizes are confusing, but then they're kind of going on and on about the size chart. So for the model, they find it difficult to kind of predict whether this person is happy or sad. And I guess as humans, we do this all the time. We always kind of like have negative and then we always fix it with positive. So how do you know whether you're happy or sad? Okay. So if we move on to Amazon as a company, so we just thought we kind of deep dive into actually the client. So Amazon actually accounts for 37% of US retail sales. So I guess imagine being a retailer on Amazon, and reviews obviously are very important. So 84% of customers actually trust reviews. So you having kind of positive reviews helps you kind of sell your products. And as I said, I'm one of those people who do regularly read reviews, and 91% of people do this as well. So that's literally most of the market are checking before they buy your product. So if you have these people using the reviews, 68% of these reviews actually concentrate on the first 6 reviews prior to making a purchase. And once you've actually got that market, 22% of people won't go look at looking onto it. So that is the power of reviews. Next slide. So we just kind of thought, like, how can we actually use this? Like, how can companies and customers use sentiment to actually decide on their purchase decisions? So as we've mentioned before, there's a kind of a world of like strength to get from reviews, and if you are able to kind of exploit that, you can obviously increase your customer satisfaction and brand loyalty. It's always easier to go from positive than pick yourself up from negative. So if you are basically looking at how your customers are reacting to you and showing improvements, you're more likely to kind of continue that brand following. Another good thing, especially because we specifically focus on activewear, and obviously the fashion market is very fast moving. You are able to kind of work out when something is going in fashion and when it's coming out, so you can actually react to the market quite quickly. And I guess one of the major things is like detecting product issues and making improvements. Especially with buying something online, we can't get the look and feel of the product until we receive it. So if a lot of customers are saying, oh, it's cheap quality and the color's not right, you need to make those improvements straight away. And stuff like, I guess, color and sizing, those are probably quick fixes. That's probably down to your product imagery or how you've done the descriptions. So maybe doing kind of size charts, scales, because obviously we have 101 scales around the world, US, UK, it's very difficult to gauge your size. So I guess going from that, then it helps customers to aid their decision making. So now I'm gonna, so we just have this slide. We just basically and the whole point of this is you don't want to be one of those kind of brands that make it to what I ordered versus what I got, because you're going to ruin your brand loyalty. So just make sure that you're following your reviews and making sure you're offering the best products and services. So I'm just going to pass on to Heather to go through the data analysis.
Hi guys. So basically, as Danny processed the 5 processes to go from our problem to our solution, I will just go through the process, which is basically to get the data. We have data from Amazon, which is around 6 million reviews, and for us, we just use 100K because we were using Collab and we have limited, rounds to use. Then we have to clean up the data. A lot of cleaning up, and we had to explore the data. And most of our problems, which Amba discussed, will be basically will be solved here. So basically, you have the brand or the product owners. They can improve their products just by exploring the data and learning more about the reviews and what people are saying. And another thing would be, and the other thing is would be about the investors. So if you are an investor and you want to invest in specific brands, so basically you want to know which products are actually caring about the quality of their product, which brand is taking into consideration their reputation, and so on. So after we explore the data, this is the EDA part. We will feature engineer to have just two features, the text and the label, which is the star rating. After that, we're running the models. And basically, we're running the models. Why are we running the models? Let me take a breath.
Calm down.
When I get excited, I just forget. Yeah. So why are we doing machine learning for data for reviews? It's basically, furthermore, if a brand wants to know how the people are talking about their products in non-star rating space, like in Amazon you have 1 to 5, but on Twitter or on Instagram, people are just talking bad about your quality or talking good, but you don't know. So basically, these product owners, they will extract import in their own ways their data and analyze the people. Are they talking good or bad? Because they don't know whether this is saying good or bad. Imagine they will get 10,000 throws, but they don't have the is it good or bad? So basically, they have to do the machine learning model that we trained.
Okay.
Yeah, my friend Sushma will go us through how we clean the data.
Yeah. So we all know in the reviews, usually we are very lazy to write a long sentence. So we just put a smiley or just mention the stars in the reviews. So we had many such examples in our review comments, which we had taken. So it was just emojis or emoticons, or they mentioned the hashtags to mention the brand owners. So as a part of the cleaning, we just started dropping the irrelevant columns. So our of the columns like customer ID, product ID, or review ID. So since we are speaking about sentiments, this ID would not matter much. So we wanted to predict the sentiment out of the reviews which they have posted, not on who has posted, or like it might be a combined. The same customer might post a good review in the next product. So we dropped some of those IDs there. And also there were some of there where we had only the star ratings, but they didn't mention anything in the reviews. So we had to drop even that. Also, there were two data sets which was telling a review headline and the review body. So we thought of combining those two and considering it as one, because that would give us like two columns which we had to measure separately. We thought and measure it as one. And also we have created the length column. So based on this length, we wanted to analyze like which ratings has more like length of the review on the ratings. So let me go to the next. In a background, you can see some of the reviews which we have just posted so that you will get an idea how it is. So we have downloaded some of the toolkits and removed those hashtags or the stop words like maybe not or like it does or something like that. And also we converted all the text into the lowercase, also tried stemming on it so that you see there is a word like boss, nothing. We wanted to reduce those sizes and we have applied the stemming on that. And also the emojis, that was a main part since we can't predict what it is. So what we did during the conversion cleaning, we converted those emojis into the text. For example, if it is angry face, the conversion would be angry face, a text. And similarly, if it is a happy face or something, it would have converted that. And also there was a emoticons, which is an older version of smileys which we were using. Even those were cleaned up.
Also this one, the HTML.
HTML tags.
Yeah, for some reasons, the Amazon reviews have that. So now we talked about the cleaning the data. We will move to the visualization. Yeah.
So we performed a correlation matrix. So correlation basically defines the relationship between characteristics. So as you can see, red is highly correlated, and then the dark blue is not so correlated. So in the middle, you can see the block where I guess total votes and helpful votes, which makes sense because helpful votes is a component of total votes. But then you can see it's not very clear, but you can see that star rating and total votes, which is the lighter blue color, have a correlation, as do Vine reviews and star rating. Just to explain, Vine reviews is where Amazon has kind of, I guess, VIP customers, and they're given a chance to kind of like do a video to present kind of, yeah. So that's how, yeah.
The verified purchase as well.
Yeah, and also the verified purchase and Vine reviews do not have any correlation. I guess everything's verified anyway, so regardless of whether you do a Vine or not. Cool.
So in the data set, we saw around 53% of them are the 5-star rating. So mostly it is a positive reviews which were there in the data set which we selected. Maybe it had something more, but since we selected only the 100K out of it, so it had a 53% of 5-star rating and 17% of 4-star rating. There was not much of 3-star rating of 2 and 3, but we can see there are some 1-star rating as well, which is a significant part of this whole data set. So coming to this, so as I told, we had put the length column, review length column. So we tried to check like which review has more words like expressed in it. For example, the star rating 3, that is the most review has the most number of words in it. So maybe the star rating 3 might be the customer who are happy with the product but not so happy as well. They might be telling us more about the size or a color which they didn't like. Similarly, when we come to the 5-star rating, it is lesser words. As I told, they might have just put the 5-star, or it is good or perfect, or just a one word which they might have used for the reviews. Then coming into the words which has been frequently used, you can see the stars and the great, love. These are some of the expressions which they have used to express their sentiments. And these are the words we can even see in our next slide in our word cloud. This is a 1-star. So the size and since it's apparel, it is different. Each person will have a different way of seeing like product. So some person might buy the product seeing some UK size or a US size, like a size chart. So for them, the size might be the main concern about that product. Similarly, the smaller, the 1-star, or the fitting and the nice looking, or it might be a beautiful but not so. They have mentioned multiple words which expresses the 1-star reviews. And this is a neutral one. Again, the dress and the size is the one which highlights the most, the material as well. And in a 5-star, we can see the similar words, the great fit, size, dress. So these are words which convey that people look into the fitting the most, the size the most, and if it is the material is good or not. And the least is something they main focus on the apparel will be these things like the fitting, the material, and the size, and also the quality of the fabric which they are using. So whenever the vendors, if they are checking the reviews, they have to concentrate on how are they expressing these words in their reviews.
And since we're still in exploring the data, we wanted, unfortunately, we didn't have the column which is saying the categories of the product. So you can have a bag as an apparel, a belt, or a dress. So we wanted to cluster. We tried the machine learning model to cluster our products. However, it took a lot of time since, you can already see we have this is using the elbow method. So having 200 clusters, having 400 clusters, and even 700 clusters makes sense. but still it doesn't make a lot of sense because we have distinct of around 40,000 different parent products. So we have to use we need a lot of RAM, and you can already see some square error. It's not even reaching to the hundreds, 100,000. It's still in 2,200. It's very high. So it was hard to categorize the data, but we did try, and we needed to do a manual categorization. So we didn't do that because we had limited time. The next thing, so what we did is to look at the top 10 rated products, rated and reviewed products. The top purchased product, was the dress and all other women related
We like to shop.
Yeah. So this also explains why in most of the word cloud you can see dress because most of the reviews were about dress. And if we move to the next slide, so here we were trying to understand from the investor's perspective, right? So this is the daily. This is showing daily reviews aggregated for all the customers, and I mean it doesn't give a lot of meaning unless we aggregate it to monthly. So on a monthly basis, you can see the product is coming from 5 stars to 4 stars after a few months, and most probably the top 5. I mean, we have 5 stars in most of them because they're not really verified, maybe. So yeah, but you can clearly see some of the products, they go from 4 to 0.5. So as an investor, I wouldn't invest in this product or in this brand because they don't care, they don't do analysis on their products. We move to the second 5 top. Yeah. So here's some products, they're actually increasing their quality probably. So it's going from 3 to almost 4 in just a few months. So this is, as an investor, I would invest in such a company. So this is kind of the analysis that can be done, used to use. Another thing we saw that this pattern of the total number of reviews. Actually, this is clean. We had just few data in 2014, and then we wouldn't. If I put it, we wouldn't have this graph. So we cleaned it up, and for some reason, the number of reviews doubled almost every month. So either this is because of the data set we have, or because really people are started using online shopping more. And just also as a pattern, we realized that on weekends we have the least number of reviews in each month. So we have this month, and then for some reason, maybe because the delivery guys, they don't deliver on weekend. So yeah, it's just a pattern we realized. And then yeah, we'll move to the what. Okay, so after we understood all the different
features, yeah.
After we analyzed the data, we kind of got an idea as a how I can increase my how I can improve my product. Okay, if I get other sentiment from other people on different social media, how can I know is it good or bad? Using machine learning. In our bootcamp, we only covered the RNN. This is because it's mostly used, and it's for text, it's sequential data, so it kind of does the NLP, the natural language processing, understands the pattern of words. The other models, they're also used in the field. However, even though we didn't learn it, but we learned the syntax, we learned the data structures. We were able to try all of them, even though we didn't take it. So thank you, Dan. So we tried all of these different models, and they're showing a bit more accuracy, probably because some of them are pre-trained, especially the BERT. This is developed by Google. It's showing 94%, but we mostly played around with the RNN because just having 2 weeks to know about sentiment analysis, we were able just to tweak a little bit on the hyperparameters of this one. So this is just to be really frank, we don't know much about all of them, but we tried them. And
yeah, we tried predicting,
Yeah, and one interesting thing, if you can go back, is that when we tried to predict a specific sentiment, so not so great, some of the models wouldn't predict it very good because they don't have the connection between the words. So they have one weight of one word and one weight of the other, but it's showing the correlation, the relationship between the words wasn't there. So the RNN model, even though it's less accuracy, but it has this relationship between the words.
Yeah. So these are some of the both model predictions which we had. So we just tried passing some of the reviews. So great product, but fitting is tight. So it has a positive review, that is great product, but also there is an issue with the size. So it written as 4. So it is not a good 5-star review, but it is having some of the comments to improvise. So it is a 4-star, and Louded the 5-star, so it predicted 5. And we tried passing not the product I would buy again. So
It was probably
it is 1. Yeah. And then with the RNN, similarly, here we can scale the reviews there. So when you pass 5-star, you can see we have 0.79 accuracy, whereas when you pass a material is bad, it's 0.16. And similarly, the small not fit, you can see it is 0.05, so which reduces. And as the reviews are better, the ratings are, the scaling is better in the predictions.
The approach one.
Yeah.
Yeah. Yeah. So we are, for the RNN model, we had to scale it to 0 to 1. Yeah. So sorry, we couldn't complete the. Okay. And now moving to our conclusion. Would you like to talk about it?
So to conclude, the challenges that we found were dealing with the text and the pre-processing. So initially we were going to drop the emojis because it was very hard to actually process it. And then we tried a few models and then finally we got to somewhere. Also trying to predict the sentiment. As I said, as humans, we're very complex characters. So we don't always just say kind of a straight line view of what we think. So as you saw with the 3-star reviews, you had a mixture of positive and negative. But also the major thing we had was focusing and prioritization. We had tabs upon tabs upon tabs of models and exploratory data and just trying to work out what we should use and what we should, so that was very difficult to kind of zone in. What we have learned, as I said, predicting sentiment, as customers can have mixed sentiment, but also working in a group. So none of us knew how to use GitHub. We learned how to push to GitHub. Sharing code, we tried to split the responsibilities. But then we did find that we had to kind of like copy and paste code because we all did EDA, and then we had to kind of try and work out whose EDA worked better and what works well. Improvement. So with the actual data, I think that having the data on the brand would have helped us because we actually would have made to see which brands are doing better versus others. Also kind of the price and the quantity, because I think it would have been interesting to see how do people actually review like cheap products or, versus like the expensive products. But also more recent data because it would have been nice to see over time like how the reviews changed. As Heather mentioned, kind of the grouping, if we were able to actually have, I guess, underwear, accessories, etc., it would have been interesting to see how the reviews change across those elements. And also better training of the model so we can get more live data from social media. So the next steps for us is to continue learning, enhance our experience in data science. And
we learned that we're just scratching the surface of data science.
Yeah, definitely. But it's been an enjoyable experience. Yeah.
Thank you so much.
Thanks, guys.
Because I'm evil. Anyways, so as you mentioned that we as humans we use complex characters, what do you do with these very modern jargons that, for example, sometimes we say something and we mean the opposite of it, like this course was sick. It's a compliment, but an AI would take it in a negative way. Or sometimes an adjective that doesn't really mean anything positive or negative, or like, again, this presentation was tight. It doesn't mean anything for we as humans, we understand it because we keep up with the jargons. But what does the AI think of it?
If I'm joking, I hope someone will ingest the Urban Dictionary and help us train them. But yeah, it's based on kind of library reviews. So I guess the English language or the language has changed. So as time progresses, we will let the model learn to kind of
For now,
ingest
we
this
have
kind of
used the
information.
SAN program,
Yeah.
which is defined. We have just used that.
We are basically just trying to implement what we learned. And also, like Danny said before, there's this Shakespearean, there's this Shakespearean library, and I think the BERT model take this into consideration. It's more some machine learning models. They said you mentioned before that they can actually write essays and summarize different articles together. So in terms of deep learning, it's already been done. But for us, we're just trying to exercise on it.
So the awkward 20% that read the reviews but didn't trust any of them. Considering this is based on Amazon reviews, is there any way that you could maybe take this code and utilize it in a different way to maybe validate that your 5-star reviews are actually 5-star reviews?
We can try. We can try that because we currently use only the Amazon reviews because of the time limit which we have. But that is an interesting. Actually, we can try putting some other data set, external data set, and train the
to improve the model. Basically.
And in general, sometimes when we were doing research, and Amazon are very hot on fake reviews, so they actually do try to filter through the data set and remove that from there, so the customers don't have a bad experience. But yeah, in terms of us kind of like...
They're also still one of the worst offenders.
Sorry?
Yeah. They're also still one of the
Yeah. Definitely.
Yeah.
But it's definitely something to consider, yeah. But I think also, I guess, with the Vine reviews, maybe that's something we can look into deeply to kind of see how that did affect kind of the star rating, because that is from a verified person. And if you trust them.
And also, I'd like to add, if the product owner does, I mean, some brands or products, they have the reputation management part of their team. So they try do their best to reply or satisfy the customer. And this also gains the trust of other reviewers that they know what they're doing and they will try to improve. So I think this having all of this analysis is also improving in the marketing field, and yeah. And I think about it.
So, sorry. Your decision to join Titles and Body, do you think there was anything that you might have lost by starting the title versus the body? Like,
so one thing, some reviewers didn't have anybody. We just had the title. So it was kind of, yeah.
And also there was one of the examples that we don't have it. So the review was 3-star, but the review comment had a good comment. So there are some people who are yeah, we don't have that. So we thought let's combine it because it's a 3-star review. Maybe he's not completely satisfied with the product.
You saw that in the 5-star word cloud.
Yeah.
It said 4-star.
Yeah.
And 5-star word cloud. So.
But it was confusing because there's lots of words in both.
Yeah, exactly.
1-star and 5-star reviews that were.
The complex humans.
True. Maybe because the title was showing dress inside.
That's right. Well, you guys know that.
Well, thank you very much for the spectacular demo. All right, so that was
the last team that demoed for us. Just a few more comments before we wrap up. And how about if I can ask? Oh, well, I won't keep you. I won't keep you for the pizza. But just a quick comment. How about if we can stop sharing the screen? And I'll leave you all alone. Now, but I really need to bring this up. So, as our first team to demonstrate the what was your team again? Cluster Champs, right? That was the cluster.
So you know the names?
No, I do know names.
Yeah, it took me like a few minutes to get together with all the
The
names.
Cluster Champs. This is our third, let's say, edition of the Data Science Bootcamp. So this is the third cohort. You know, when we first put together the curriculum, we thought there is no easy data science or difficult data science. You either do it right or you don't. And the bar is quite high to get into the discipline. If you just keep in mind the last demo that we had, you have to do a lot of manipulation with data. You deal extensively with complex data structures. That's a term in computer science. So you have to be competent in programming language. That's one skill set. But then you want to use statistical techniques. That's what machine learning is, using statistical techniques to infer information from data. You have raw data, and when you look at it, initially, nothing is apparent, no pattern emerges. And you hope that through the employment of statistical techniques, some pattern will emerge. So you need to use programming to play around with the data, but in order for you to know what type of statistical technique to use, you also need to be good at statistics. But to be good at statistics, you have to also be good at probability theory, because statistics is not a mathematical discipline. It is mathematical in nature because it requires probability theory. Okay? So you have to be good at programming. You have to be good at statistics. You have to be good at probability. Oh, but it turns out if you want to be good at probability theory, you also have to be good at calculus and linear algebra. Because if you're dealing with matrix type data structures, like a CSV or an Excel sheet, that's a matrix. You need to be good at linear algebra. Oh, but if you want to know if a model is good at what it's doing, if it's able to find out why a certain feature, why a certain explanatory variable is useful, you also need to know calculus, because you need to find something we call the gradient. So you have to be good at programming. You have to be good at statistics. You have to be good at math. Oh, you also need to know something about the domain, right? Because say you were talking about the reviews, right? You need to understand that online you will encounter different forms of reviews. Some people can be quite expressive, whether they're upset or they're happy. They will talk aloud. They will write lengthy reviews, and some people might not just are happy with the star. I'm such one person. When I'm happy with a product, the most I do is give them a 5-star. But another example was fraud detection. Who decides what is? How do you know what is fraud? So it turns out in the finance industry, you really do need to know. There needs to be clear definitions of what constitutes a transaction as fraudulent. So on top of everything we talked about, so we said programming, statistics, mathematics, and domain expertise. Someone who can check these boxes is, as you can imagine, very difficult to find. And someone who can do those things must have had a lot of years to prepare. They either studied mathematics in university, and then later on they picked up programming, and then, if they worked at a company, through the passing years, they managed to learn more about the domain. Or conversely, someone studied, had a lot of experience with computer programming, but they picked up more mathematics on the way, and then they got employed. The point I'm trying to make is, it is unbelievably demanding in terms of technical acumen and even business acumen or organizational acumen. Not only do you have to have a lot of experience in a particular domain, you also have to have a lot of technical expertise. So you can imagine how difficult is it to find someone like that. And it takes years to cultivate such extraordinary skills. Still, we had to come up with a boot camp that was only 2 months in duration, and the participants would come to the boot camp we would assume they had none of the prerequisites, and they would make it to the finish line having acquired substantial programming experience, substantial experience in, well, not experience, but knowledge about the mathematics, and they would bring in their pre-existing domain knowledge, because almost everybody in the boot camps are working professionals, to they had to do all of this to get to the finish line. Moreover, the curriculum is not well established yet. So to put together the curriculum, we have to go into graduate level textbooks. Like the topics that we cover are taught in graduate school. Meaning if you want to learn this in graduate school, that implies you had studied, that you have the programming and mathematical prerequisite to do it. And a master's program is a year or 2 years long, but you would have done 4 years of education before that. So that's what it takes to become a data scientist. But here we have 2 months to do it. So even though this is the third time we're doing it, it is still very surprising to see that people can still, you manage to make it to the finish line because it is so difficult. And I try to dumb it down, I try to play it down. Oh, this is not so bad. We will do it easily. But in reality, it's so difficult. I sometimes wonder if this is too much. So I've been in computer science, since I was 18. I learned this stuff in middle school. I studied this at the undergraduate level, then the postgraduate level. Right now, I have over a decade of experience. So I think to myself, if I was put through this, would I make it? And it's hard to say yes. I like to think that I'm I have the fortitude to make it through. But 2 months for this kind of content is just a bar too high. So I want to congratulate everyone for two reasons. Reason number one, making it to the finish line, considering how intense the bootcamp is. Number two, your resolve and fortitude. Not only you have full-time work, some of you study, and you still show up late in the evening, like 6:30 to 9:30 every day, on weekends, and you have 2 months not only to learn but to work on a production level project. So big massive applause to you. Unbelievable accomplishment. I have massive respect for all of you. With that, everybody, I want to thank you all for joining us. I want you to enjoy your evening. If any of you have any questions about the program or anything we talked about today, you can find our contact information on our meetup page and on our website. So I look forward to seeing your question. But until next time, take care. Bye-bye.